So we're going to start the webinar now. Just about myself, I am having an industry experience of around 13 years working in big data technologies, Linux, Java, and Amazon Web Services Cloud. I've delivered more than 80 trainings on Hadoop administration and have educated more than 2,000 students in this field. So based out of Pune and working with a multinational company and with edureka from past 2.5 years now. So today the topic of our webinar is setting high availability in the Hadoop cluster. And what you will learn today in this webinar is Hadoop. It's a synonym for big data, how it is, what it is all about, Hadoop high availability. So we're going to talk about the high availability stuff. So basically it's an advanced feature in the next version of Hadoop, which we talk about today, which we're going to talk about today. And then we are going to do some hands-on as well, how to achieve the high availability in the NameNode and yet another resource negotiator. And then we'll do some hands-on on the security part as well, how you can secure your storage. And then lastly, we'll talk about the Hadoop as a data warehousing solution. So at any point of time, guys, if you have any questions you want to ask, please drop your questions into this questions window. I'll pick it up and I'll reply to your queries. However, if you have any queries after this webinar, you can reach out to our sales team and they will certainly resolve all of your queries, whatever you have regarding the course or regarding anything, I mean, if you have. Okay. However, if you have any technical queries or anything like that, just drop your queries into this questions window and I'll pick it up. Okay. After this webinar, okay, there will be a survey feedback for this. So please do not forget to fill that survey feedback report. It would be really helpful for us to understand what are your concerns and what do you think about this webinar as well as our services. So let's quickly start now, guys, and understand first a bit about Hadoop and its high availability feature. Okay, so we're going to talk about the same thing in Rajiv in the Apache Hadoop. Okay, we're going to take the Apache Hadoop as our distribution. Okay, very basic one, which will actually be helpful for everyone to understand as it will be from the scratch. Okay, so what is Hadoop all about? Apache Hadoop is an open source, scalable and reliable solution that stores and allows distributed processing of large data sets across clusters of computers using simple programming language, simple programming model. So basically Apache Hadoop is an open source distribution. Okay, like today what has happened is, I mean, Hadoop has gone a bit. Okay, it's it's not the same thing like we have 2 years back, or I can say a year back as well. So earlier, like we had just the Apache Hadoop distribution. Apache is a organization, okay, which which this Hadoop came up, and then it provides you the open source distribution of Hadoop. Like in Linux, we have got various flavors of Linux, right? Ubuntu, SUSE, Red Hat, CentOS, etc., etc. But they're all like say having same sort of Linux only. So in similar to that, in Hadoop as well, we have got different distributions. Okay, Apache Hadoop is an open source distribution. Cloudera, Hortonworks Data Platform, Mappa, Big Insights, these are all using the Apache Hadoop only, but they have included some more of their proprietary tools. Okay, so if we talk about the Apache Hadoop solution, it's an open source solution. So it's one and the same thing, whether if you're using the Cloudera or Hortonworks Data Platform, or let's say IBM Big Insights or Mappa, anything like that. Okay, they're all using the Apache Hadoop only, but they they have customized this solution to make it aware of their own tools as well. Okay, so like Cloudera uses Cloudera Manager to manage the entire distribution of manage the entire cluster. Okay, so with Apache Hadoop, you don't have to do, you don't have anything such like that. You have to manage it manually of your own. So it's a scalable solution because you can add the storage, you can decrease the storage, you can decommission your data nodes on the fly without even bringing down your cluster, without even telling that okay, I'm doing this thing. So it's quite achievable. Reliable solution because the Hadoop solution itself has got a replication factor sort of thing. what that replication factor says is whatever data you are storing into the cluster, or let's say whatever data you are storing into the storage part of the Hadoop, storage component of Hadoop, that will get automatically replicated or duplicated into multiple nodes. Okay, so that brings the reliability. Let's say if one of the node goes down, you can bring the data from the other node. If the second node goes down, the data can be brought from the third node. So that brings some of the reliability as well into the Hadoop distribution. Okay, now it's all distributed because the data is not stored on one node. The data is distributed on multiple nodes in the cluster. So when we say cluster itself is a group of nodes. Okay, so in this case we have got cluster of servers. Okay, so the data basically is being distributed on these servers, and we have got, like, I mean, it can be a huge storage per server, like it can be 10, 15, 20 terabytes of storage per server, and accordingly that data can be distributed by the Hadoop distributed file system. And then to process that data, Hadoop has a second component called MapReduce. So MapReduce is the component that will actually help you to analyze the data, but it's a very low level programming model. Okay, using Java you can analyze your data, which is certainly being used, I mean highly being used in today's organizations, but lot of people have gone into some Hadoop ecosystem components as well. So for example, you have got Hive, Pig, Impala. So those solutions have also now come up where basically using instead of using this low level programming model, they are using some SQL solutions. Okay, like Spark SQL is there today. It's a very latest solution through which you just need to write your some SQL queries, and you can do the all the analysis via that. See, try to understand that the major goal of any organization or any solution is to bring the profit, right? You don't want to write lot of lines of code, okay, thousands of lines of code, and try to just store the data because Hadoop is a buzzword today. It's not like that. Okay, Hadoop has just been come up because it was easier to analyze the data, which was actually being unused. Okay, but people were not able to even store that data or not able to analyze the data. Okay, like very simple data we can take is server logs. Okay, they were there earlier as well, but there was very difficult way to analyze the data, to analyze those logs. Okay, but today, because of the help of Hadoop, you can store the data easily into the cluster. Okay, you can analyze the data using the Hive queries, or let's say Pig queries, or Impala queries, or various solutions are there, I mean, today available. Okay, and then you can I mean do all the reporting and all you with the help of MicroStrategy, or let's say ClickView or Pentaho. All such tools are already available in the market. Okay, so Hadoop is the solution which will actually help you to store that huge amount of data. Plus, it will help you to analyze the data using some Hadoop ecosystem components. Or if you don't want to use that, you can use the simple low-level programming model, which is called MapReduce. So, if we take a closer look at Apache Hadoop, okay, there are four components of it. Okay, one is your Hadoop distributed file system. So this distributed file system is uh, the component that helps you in storing the data, okay, in the distributed format. So when we say distributed format, this distributed format comprises of two things. One is called metadata, and second is called the actual data in the form of blocks. Okay, so that metadata contains the data about data, right? So metadata means only, I mean, the definition of metadata is data about data. So what kind of data about data that will be? Like name of the file, size of the file, timestamp of the file, permissions on the file, ownership of the file. All such kind of metadata is being stored inside the one of the most important and master component of the cluster, which is called NameNode. So it's a process which will keep on running in the cluster, and it will store all the metadata inside it. Second service is called data node. So HDFS exposes two processes. One is called a name node, which will be one per Hadoop cluster, and second is the data nodes, which will be multiple per nodes, multiple per slave nodes. Okay, I mean to say there will be multiple data nodes in the Hadoop cluster. So data nodes are responsible for storing the blocks of the data. Name node is responsible for storing the metadata of the data. So without name node, you cannot recognize the data. I mean, the HDFS will not be able to recognize the data because NameNode metadata only tells that okay, which blocks of the data are being are being comprised of what file, or let's say how the file to block mapping is being done, or how the block to data node mapping has been done. So location wise or blocks wise, every such kind of information is being stored inside the name node. So that is why distributed file system is the storage component, and it's one of the important part, because if the HDFS goes down, nothing will happen on the cluster. Nobody can do anything inside the cluster if HDFS is gone. Second is your Hadoop common. Hadoop common is the common utilities that support the other Hadoop modules. Okay, like you want to talk about the you want to access the HDFS, you want to access the yarn, you want to run your MapReduce queries. All such utilities are being provided by Hadoop commons for that. Okay, then you have got Hadoop yarn. So yarn is basically a next generation MapReduce framework, which I was talking about 2-3 minutes back only. That helps you in actually uh, basically doing the resource management for the cluster. I mean, whenever you are basically running the jobs on the cluster, or let's say running some applications on the cluster, how those applications will get the effective the resources on the cluster, this will be managed by yarn. Okay, and the specialty of yarn is, I mean, not only MapReduce but other workloads can also run. Like Impala does not use yarn. Okay, so Impala is the SQL framework only to run your queries on top of the data lying inside the HDFS. So Impala can run. Then you have got Spark. Then you have got uh, Giraffe, MPI, H-based coprocessor. These are very latest terms. Okay, you might want to go to page of Apache Hadoop powered by Yarn, where you will see all these frameworks and their descriptions. But just giving you an idea that if you want to do the job management, for doing the job management and the resource management on the cluster, Apache Hadoop Yarn is the answer for that. That is the latest tool for Hadoop. Okay, so we are going to see the high availability as well. I'm giving you the basic here, but yes, when we'll come on to the high availability stuff, I'll also show you how you can achieve the HA in the HDFS, which is the name node, because name node is the utmost important component of cluster, and it is one per Hadoop cluster. So if we have like one name node, and if the name node goes down, certainly there won't be any HDFS. Okay, so you want that there should be two processes of name node at least, like one will be active and one will remain standby. If the active goes down, then at least a standby should come up. And similar to that, in Hadoop Yarn as well, there are two components alongside. One is called resource manager, and second is called the node manager. Similar to name node, resource manager is also one per Hadoop cluster. If resource manager goes down, you won't be able to run the jobs on your cluster. So for that also, we want to bring the high availability. In a sense, one active resource manager and one standby resource manager. If the active goes down, standby should start the job from the same location, or let's say same state where the active was down. And then you have got node managers. So if we take the architecture, name node is the master, resource manager is the master. Name node will be one per cluster, resource manager will be one per cluster, and both are the master daemons. Okay, and you have got data node and node managers. They are deployed on all the data nodes, I mean all the slave nodes. Okay, so for data management, HDFS comprises of two daemons, name node and data nodes. And for MapReduce, we have got resource manager and node manager. And under this as well, we have got MapReduce, Hadoop MapReduce. So a yarn-based system for parallel processing of large data sets. So what MapReduce is actually? MapReduce is the workload. MapReduce is the workload running inside the yarn. Okay, that helps the MapReduce specific jobs to get the resources from the cluster. So yarn is the master who will provide these resources to run the MapReduce jobs. And this MapReduce component also comprises of two more services. One is called application master, and second is called the container. So when we say resources, when we say resource manager provide the resources to the cluster, what kind of resources those can be? The resources can be in the form of memory, CPU, hard disk. Okay, So those resources will be provided by the resource manager to each job running in the cluster. Okay, so I think everyone is now clear, right? So three components, if we say, okay, HDFS, we have got NameNode and data node, right? And we have got yarn, resource manager and node manager, and we have got MapReduce, in this case application master, as well as containers. So I'll say yarn child containers, okay, because these are the child containers coming from the yarn. Okay, and if we talk about the master daemons, we have got NameNode, we have got resource manager, and if we talk about the slaves, data node and node managers. Okay, so this application master and yarn child containers, okay, they are created always on the fly. Okay, always created on the fly, and once the job is finished, they will also be stopped. Okay, so they will only come up during when the job is running. If the job is stopped, then this application master and the yarn child containers, they will also get stopped. Okay, so if we just give a one liner, stores metadata, provide resources, stores blocks of the data, okay, and provide resources after getting instructions from resource manager. Okay, so resource manager is the one who is the master, but it always provide the instructions to the resource manager that okay, so and so resources are being required, please provide the resources to the application master. So application master, one per application, created on the fly, stopped once the job is stopped. Container, multiple per applications, map and reduce tasks, run in them. Okay, it's a group of memory, CPU vcores, okay, and hard disk. So these are being provided by the containers. Okay, but both of these are being created from the by the node managers. So node managers create below after getting instruction from resource manager. That's the basic things of all these components, guys. Okay, so if we take all of these, okay, as this master component says, stores metadata, provide the resources. Okay, if NameNode is down, nothing will happen on the cluster. Nothing will happen means no job can run, and no one can access the HDFS as well. Okay, if resource manager is down, HDFS can be accessed, but no job can run. Okay, so if you see their importance, I mean from the master nodes perspective, both are very important. I mean highly critical, if I say. Okay, so what Hadoop has come up with the solution called high availability. Okay, so in distributed computing, failure is a normal thing, which means yarn should have acceptable amount of availability. Also, NameNode should have the acceptable amount of the availability here. Okay, client is running some jobs, okay, or is trying to read the data. If the NameNode goes down, certainly there won't be any high availability into the NameNode. Okay, so it won't be able to fetch the data. Okay, now in NameNode, okay, in the HDFS, okay, by default Hadoop has come up with some another solution, which is an old solution actually, called secondary name. Okay, so it's a, I can say, partial savior for the Hadoop solution. Okay, but it's again not really recommended. But if I want to give you a brief idea about this, secondary NameNode is, I'll say, backup node for NameNode. Okay, not a hot standby. Okay, backup NameNode metadata every hour after hour. Okay, saved metadata can rebuild your primary name. Okay, but the challenge with the secondary name node is actually its work behavior only. I mean to say, the third point, backup name node metadata every hour after hour. Okay, so over the wire, over HTTP only, it tries to back up all the data. Okay, which is again very problematic thing. The reason is obvious, that let's say your metadata goes down to around 50 gigabytes. Okay, so every hour copying a 50 gigabyte of data is not a sensible approach. Second thing is, let's say just 5 minutes before the hour is coming up, or before the backup operation is coming up, your primary name node goes down, which means you will lose that 55 minutes of the metadata. So if the metadata is lost, certainly I mean all the data is being lost of that 55 minutes. So you don't want to do that. Okay, you don't want to you don't want to use such kind of solutions in this case. So that is why I said that secondary name node is partially being used. Okay, in cases where you don't want to use the name node high availability. Okay, but let us see, because this is the most recommended solution, high availability in the name node, and is being configured as well in almost every cluster today. So let us discuss about that. Okay, what is this name node high availability? So a bit complex architecture, a bit complicated here, but let's see how it works out. So there are multiple components involved in the HA part, guys. Okay, now HA is common between the name node and yarn as well. Okay, so if we take both the HA, okay, so both name node and uh, yarn, or let's say resource manager, okay, they have the common uh, way of achieving the high availability. Okay, under this basically three components come up: journal node, concept of journal node, then you have got zookeeper and zookeeper failover control. Okay, so simple idea between the, if we talk about the name node here is, okay, the simple idea here is that one active name node, okay, should write some data into a shared directory or shared storage, which will be shared between both the name nodes. Okay, active one and standby one. So write some data, uh, write this metadata into the shared storage, okay, which is comprised of these journal nodes, and standby name node will keep on reading all this data. Okay, so every transaction will be read by the standby name node, and if the active name node goes down, because the data nodes are connected to both the name node and standby name node, which means already the block advertisement is happening. Okay, block advertisement means data nodes are already telling both the name nodes that these are the blocks I have. Okay, so if the active name node goes down, then standby name node already has got the metadata from this shared storage and the block advertisement from the data nodes. So if the standby name node has got both of the stuff, which means standby can start from the same state where the active has gone down. Okay, so the idea is that both the name nodes, active and standby, should have some shared storage. Okay, so if we see the next architecture, that is also of high availability but a bit more clear and gives you some more understanding as well, how it is working. So if we talk about this high availability, in this case you can see a shared edit logs. Okay, all namespace edits logged to shared NFS storage, single writer fencing. Okay, yeah, Deepti, I'm coming on to that. Actually, I have not yet talked about the zookeeper part, but just Just hold on for a sec, okay? So I'm just talking about the shared part first only. So this shared edit logs, this can be a NFS server, okay? It can be anything. I mean, that totally depends upon you. What do you want to configure? Okay, you can write your own custom solution as well. You can do with the what Hadoop is providing. Either use the NFS server, like in this case, or use these journal nodes. So journal nodes are also doing the same thing. The idea only here is, the difference is, these journal nodes are multiple in number, right? You can start multiple journal nodes, which means if one of the journal node goes down, then at least two can still make it more highly available, right? I mean to say, if there are three journal nodes, one goes down, still two are there for achieving the HA. Okay, but in the case of NFS, in this case, certainly if the NFS goes down, I mean, NFS itself become a single point of failure in this case. Okay, you don't want to do that. You don't want to configure the single point of failure to achieve the high availability. Okay, so it itself become a single point of failure, but yes, this can also be achieved. So in this case, NameNode is trying to write some data into the group of the journal nodes, and standby NameNode is reading all these shared data. Now, how this whole failover is happening here? Okay, so journal node is trying to keep the journal of the data, because okay, I mean, whatever the transaction is coming, journal node is storing all the transaction, and if that transaction is, I mean, if the acknowledgement is coming from the journal node, then that particular transaction is being called as successful. Okay, so idea is to have the odd number of journal nodes. Okay, odd number means 3, 5, 7, 9. You can keep it at any number, but generally it is always 3 in number, because to achieve the HA, I mean, if the majority of the journal node goes down, let's say out of 3, 2 goes down, then failover will happen automatically. Okay, so basically to achieve the failover, one of the other state is, if it's out of 3 journal nodes, 2 goes down, then failover will happen automatically. But you can't have even number of journal nodes. Okay, so with the metadata only, the recent metadata is being stored in the journal node. Shared edits, right? You can see shared edits. So all the edit logs. So if we talk about the two important stuff in the NameNode, okay, one is called FS image file. FS image is the persistent metadata. Persistent, okay, persistent metadata, and edit logs, edits. Okay, this is basically your recent metadata. Okay, so metadata can be anything, as I just said. Metadata can be file change, permissions change, okay, ownership change. It can be change the name of the file. It can be anything. I mean, copying the file or creating a file, but whatever it is. Okay, that can be anything. Okay, so the name comes from this only, shared edit. So these edits are being shared via these journal nodes. Okay, so that's right, Ravi. Okay, certainly there is a checkpoint on the journal node, like after 10 megabytes of the data, journal node will automatically be emptied. That's right, Ravi. That's right, Deepti. No, Vikas, all the three are active. As I said, if the two goes down, one will be, I mean, that will be basically a failover state. So certainly there will always be odd number of journal nodes, and all will be active at all the times. Okay, because they are all storing the recent edit logs. I will show you. Okay, I will show you in the web interface how it is working. Okay, just give me some time. I will show you. But I want to now give you focus. I want to take your focus from here to now how the failover is happening here. Okay, now in the case of failover, we have separate set of daemons called Zookeeper failover controller. Okay, very important daemon in this failover process. Why? Because this failover process, okay, if you see, okay, monitor liveness and health, and what it does, monitor and try to take the active log, monitor and maintain the active log. So what this Zookeeper failover is currently doing, okay, this failover controller is storing some session information. Okay, what the session information is, which name node is active, which name node is standby. So this session information is being stored inside this Zookeeper service. Okay, which means if this Zookeeper failover controller, okay, I mean to say this Zookeeper failover controller is sitting on the active name node, and this zookeeper failover controller is sitting on the standby name node as well. So if this zookeeper failover controller detects that okay, active name node goes down, it is maintaining this session information inside this zookeeper service. What zookeeper service actually provides? Zookeeper service provides some Z nodes. Okay, it provides some Z nodes. Basically, you can say simple in the simple words, it is storing some session information, or it is storing the active standby elector log. Okay, so it is storing that information. Once zookeeper failover controller comes to know that this active name node goes down, okay, this zookeeper failover controller, the active one, will change the session information here. It will change the session information here. This zookeeper failover controller, because it is also connected to the same zookeeper service, it is reading that session information. It will come to know that this active name node has gone because the session information is changed. This will automatically start the failover process. Now, failover process is very interesting as well. In the failover process, standby name node ensures that whether the active is still active or not. So what it does is it SSH into the active name node. It SSH into the active name node, kill the active name node process if it is running, and then it becomes the active. Okay, then it becomes the active here. So in this case, what is happening here is it is trying to zookeeper failover is trying to control that failover part. Okay, it is controlling that failover, which will monitor and maintaining the active log, where in the zookeeper service. So you can always have, like, you can have one zookeeper as well, you can have two zookeeper, you can have three zookeeper, but generally again we keep three zookeeper services. Okay, three zookeeper processes. So all in all, if we say there will be one master node, okay, you will have name node here, active one, you will have zookeeper here, first zookeeper, you will have zookeeper failover controller here, active one, excuse my spellings, and you will have master 2, same thing, name node standby and standby, and you will have data nodes. Data nodes can be in any number, right? 1, 2, 3, 1 to n. Okay, but they will have data node process running and node manager process. Okay, so ideally what we do is, I mean, what we actually do in the organizations, okay, we create always three servers. Okay, master and management server. Okay, and this is how we'll define. So we'll define name node here, and we'll define journal node here. Okay, and zookeeper 1, zookeeper 2, zookeeper 3, and zookeeper failover controller, zookeeper failover controller. This is how generally we do in the orgs here. Okay, so Basappa general node is basically storing the recent edits from the name node. See, think in this perspective, guys. Now, to be in sync for these active and standby name node, what do they need actually? Okay, to be in sync uh, for these both name nodes, what do they need? They need the recent metadata, right? Whatever data I'm writing here inside the HDFS. Okay, both the name nodes need the recent metadata. Recent metadata will be coming from this shared server. That's all. That's the only thing you need to understand right now. Okay, this journal node is just storing that recent metadata. Okay, by providing a shared storage. Okay, correct. That is right, Masabraj. Exactly. Okay, so in this case as well, I'm just putting that shared edit storage, shared edit logs in this general node. So I will show you my configuration as well. Okay, let me show you. So if you see, you can see here I've done some configurations here. Okay, so we do explain all these things in the courses. Okay, that's a separate thing altogether. But yes, you can see a shared edit directory being configured here like this. Okay, so we have got these three general nodes. Okay, we have got some port number of these general nodes, and then there's a way to write all these things, and we have got some failover controller as well. So both of these things are being provided inside both the name nodes. Okay, and when we enable the automatic failover, and this is my zookeeper, so I'm using three zookeeper servers. I'm saying 51, 52, and 53 will be my zookeeper servers. Okay, along with it I'm saying the fencing method as well. Fencing, what is fencing? As I just said, fencing will be basically SSHing into the active name node from standby to active, kill the active name node process if it is running, in case if this is running, and then standby name node will promote it as the active name. Okay, so you can keep the general nodes in the separate nodes, that's totally up to you, but because they are very lightweight processes, so generally we keep our architecture like this. Okay, master node, master node, master node, so two master nodes. Okay, and one management server. Okay, like this we create our architecture generally. So in this case what I have done is I have got all the same nodes only, so I've got something like this. In my case, here in the demonstration part, I have created this as a master node as well, and here I've configured data node and then node manager, resource manager, like this. Okay, so if we take our next figure of the yarn architecture high availability, same thing, exactly same thing which yarn is also doing. Okay, the difference is only in the session information which is being stored inside the shared storage. So this shared storage, okay, now will be the zookeeper servers. Okay, all this data of this shared storage will go into the zookeeper now. Okay, which will hold this all this information, which will complete this part. This will be provided by the zookeeper failover controller. Again, if the resource manager 1 goes down, certainly the resource manager 2 will come up automatically, like in this case. If you see, this will be a more clear architecture. So in this case, there will be a resource manager state, resource manager active, and resource manager passive. Okay, zookeeper failover controllers are being deployed on both the resource managers. Okay, if the uh, zookeeper failover controller detects the failure, the same information is being stored inside the zookeeper now. So zookeeper will automatically provide that information to the resource manager standby, which is becoming active now. Okay, so job will start from the same state where the active went down. Okay, so out of all these things, okay, now let's conclude this whole thing. So if we talk about the whole thing, zookeeper service is the utmost important because all the session information is being stored inside the zookeeper service. Okay, even if the general nodes are down, okay, only your HA will not work, but still your uh, the name node will still keep on working. So general nodes are also active. Zookeeper failover controllers helps in providing the failover controller part. Okay, so they control all the failover scenarios. Okay, so if we take in this architecture here, I have done some configuration for the uh, resource manager. Sorry, this is the node manager, and this is how my resource manager parties. I've done some configuration for the resource manager as well in the yarn site.xml. So just giving a brief idea, giving a cluster ID to my cluster, and then enabling the high availability for the resource manager, providing a client failover proxy provider. Now this is very important class and interesting one as well. Okay, what the client failover proxy provider actually does. Okay, now what do you don't want? Okay, you don't want that when the failover is happening, okay, all the client jobs will get failed, right? So you don't want to do that. You don't want that client jobs get failed during the failover process. So what this failover proxy provider class actually does is, it avoids that whole thing. It avoids by providing a failover class to both the resource managers. Once the active goes down, it provides the support to the jobs in a sense that it will help the jobs to start from the same state where the resource manager active was down. So resource manager 2 will actually uh, start from the same state where the resource manager active was down. So resource manager standby will start from that state itself. So proxy provider will help the jobs to actually complete them from the same state itself. And that state is being stored inside this Zookeeper resource manager state store. So these are other some of the components configurations like host name and the IP addresses. Nothing much. So if we want to start all this scenario, okay, I mean, whole lot of steps are there. We need to first create our Zookeeper servers. So I'll create 3 Zookeeper servers here, as I said. And now these are some of the steps here. Now this is first step is to start the journal node. So I'm going to start the journal node on all the 3 machines. This is my journal node 1. So you can see all the processes by running the command Java processes JPS. Okay, this JPS command lies inside the JDK. You can see. So if I run the JPS command, it will show me the journal node. You can see one process has come up. You can list the process as well. You can see coming from the Q journal server. And then if I go to the NameNode 2, I will need to start another journal node. Absolutely, because no, same servers. We are not using the different servers. In the production as well, you will use the same servers. No difference. Okay. So you can see if I run a small for loop here, 3 journal nodes are running on these 3 nodes. Okay. Now I generally, I do very detailed these things in the classes. Okay, because like here, if you see at the back end, I'm running a virtual VMware workstation and I'm running 3 VMs here. Okay, I provided some configurations to each VM. Okay, so that's why all these configurations are running clearly. So once I do that, I need to format my name node and start the name node process. So now one name node has also started running, if you see. Okay. Now what I want is I want to have the same set of data, same set of metadata, sorry, on the name node 2. So I do an SSH into the name node 2, and what I will do is I will run a bootstrap standby command. Okay, I will run this command. What this command will actually do, this command will copy the same set of metadata from the active name node. Okay, if you see about to bootstrap standby ID name node 2, from where? From name node 1. So this is the advantage. Okay, and once it is done, I will start NameNode here. So now if I run my shell script, you can see I've got two name nodes. Okay, but you can see, I mean, currently, just to give an idea, both are not active or both are not standby. Okay, because I don't have Zookeeper servers, I don't have Zookeeper failover controller servers. So what I will do is, the next step will be to start the Zookeeper servers. Yes, that's right, Bharat. Both the name nodes should have the same set of configurations. So I will say three Zookeepers. So now you can see quorum peer main has come up. Okay, some more detail can be seen via like this. Two name nodes, three journal nodes, and three Zookeeper nodes. So now the next step is to start the data node as well along with it, and we'll finish the architecture with the Zookeeper failover controller. So let's format the Zookeeper failover controller. So you can see start Zookeeper failover controller, and same we need to do on the NameNode 2 as well. So what this Zookeeper failover controller is doing here, this Zookeeper failover controller is trying to make one name node as active and one name node as standby. Now once I start this process, okay, first of all let me show you the whole thing. You can see currently these processes are running now on the cluster. Zookeeper failover controller, Zookeeper, journal node, and the name node here. Same thing on the name node 2 as well. And without Zookeeper failover controller, we are running on the data node 1. Okay, but if I now want to get the set service state, so if I check out the service state of my name node 1, okay, what it says, you can see name node 1 is currently active. Now this is just a way to find out the status of my name nodes, and another name node is in standby mode. Okay, we can find out the same information from the node as well. If you see 51, one name node is currently in active state. Well, Nagaran, there are ways actually. Okay, would like to do that in the next class probably or next webinar. Yes, but there are ways. Okay. Yeah, I mean surely. So, but let's say this is my name node 1, this is my name node 2. Okay. So now what I want to do is I want to do some testing as well, right? So as an administrator, I want to make sure my cluster has been worked fine, right? So it's now being configured with the high availability. What I want to do is I want to kill the active name node process, right? So that will certainly serve my purpose. It should make the standby name node as active. Okay, I hope everyone agrees with it, right? So if I kill my active name node, it should show the standby name node as active, which means it should show name node 2 is in the active state. So if I kill this and if I do a get service state on name node 1, okay, what does it show? Let's see. It says exception here. I am not able to reach the name node 1, which is totally fine, as this is what I was expecting from the name node 1, as I have killed it. But how about the name node 2? Okay, so great. So we have got the name node 2 in the active state now. Okay, and same thing if we go at the back end. Okay, you can see name node 2 is now become the active. So if it has become active, let's see what happens here. Okay, name node journal status. Okay, it says quorum journal manager. These are the three nodes, journal nodes, writing segment. So one is writing. Now the active one is writing here, and this is not reachable. So I'm not able to reach this. So if I want to, I need to restart this. I need to restart. So once I restart this, Let's see. NameNode 2 is still active. Great. How about the NameNode 1? It's in the standby state. So if I go at the backend, what does it say? It says standby. NameNode 1 is in standby state. It's in standby as well as the journal status. You can see it's in readable mode, open for read. So standby, reading, and active one is writing. Okay. And if we talk about the Zookeeper part as well, right? So let's see what Zookeeper is doing as well. So I've connected to my Zookeeper. You can see active standby elector lock. So that active lock is also being maintained by the Zookeeper. Okay. But how about the yarn part? Okay, so let's talk about the resource manager part as well, because it's also very important. It helps us to run the jobs. Yeah, just a second, Ravi. Okay. So resource manager has also come up now. Question from Ravi: what happens to edit logs when NameNode 1 is down and standby become active? So that standby one which has become active, Ravi, it will start writing the edit logs. Okay, and they will start getting storing in they will be stored inside the journal nodes. Once the down name node, once that down name node will come up, all those edit logs is being shared between that standby name. Okay, so edit logs will keep on coming up. Okay, so if you see, we have got the resource manager as well here, which is totally cool. So if I talk about the service stat of the resource manager, you can see resource manager 1 is active and resource manager 2 is currently down, standby. And we can bring the node manager up as well. Seems it's running at the back end. Okay, so you can see the source manager also come up now. Lot of processes now on each node. Okay, so I hope you've got some basic bit of idea like how these things are working. Okay, certainly webinar is not that detailed here. Okay, but I've tried a bit of idea to ensure that you have got some understanding how these things are actually coordinating with each other. Okay, and similar thing, I mean, so if we talk about the security part as well, okay, how will you secure your HDFS? So how will you access your HDFS? You will see HDFS commands, HDFS DFS -ls. Okay, this should give you the HDFS command, Hadoop distributed file system storage. So by default it is empty, you will not get any output here. Okay, but if I create a directory, it should show me some it should first create a directory and then it will show me some results. Okay, so nothing here. And if we create a directory, let's say an input directory, bit slow because I mean running on the single laptop with the same network only. So yes, it will certainly show me slow, very slow. So okay, that's fine. So we have got some output. Okay, but the last bit of piece from here is if I want to control the access to my directories, okay, I can use the access control list. Now the access control list of Linux and HDFS is 95% same, I'll say. Okay, there are very minor differences, okay, between them because this is the distributed file system. uh, okay, So if you see the access control list here, it is showing me some user group and other information, which you can see from here as well. Okay, but how about the extended access ACLs? Okay, so what we can do is we can say set FACL -m. I can say user Rahul. Okay, he should get read write execute access, but his group, but let's say other group of developers 3 should only get read access only /input directory. So I can provide the access to each directory as well. Okay. Ram says, what is the role of secondary name node? Ram, as I just said, it is an old daemon, old process that helps in backing up the primary name node's metadata. Okay. So let me just finish this. Okay. So once this ACL is set, you can use get FACL command again to find out the access control on the /input directory. You can see more information about this, /input now. Some more access control. Okay, so you can see now user Rahul again. So why we use basically these ACLs here? Okay, let's say, I mean, why this simple change mode or change ownership command was not suffice? Okay, see, we use these ACLs basically because if we want to provide the access to multiple users or multiple groups, okay, very controlled permissions to multiple users and multiple groups cannot be done via the change ownership and change mode commands. Okay, so that is why we want to give we have given this whole ACLs part, okay, for the HDFS access. So as I said about the secondary name node part, okay, secondary name node is a backup node for the primary name node, which is not a hot standby, but backup the name node's metadata every hour after hour, and saved metadata can rebuild the primary name node itself. Okay, but it's not a reliable node as well. So I would not encourage at all to anyone use this particular process, as you might lose the data in this case. Okay, so I think this is something from our webinar today, guys. Okay, showing a bit of about how this high availability stuff is working. Okay, this is our course details. If you want to learn how to administer Hadoop cluster, you can reach out to this website link. The next batch is starting from the 12th of December. This is a weekend batch, and the Hadoop administration course includes all of this stuff: how to set up, secure, monitor, and tune the Hadoop cluster. So I've not gone into the Kerberos part today. Online live classes of 24 hours, assignments of 30 hours, project of 20 hours, and lifetime access plus 24/7 support. So we do cover everything. Yes, we certainly cover the Cloudera part as well, Bharat, but not in that detail, because I explain why Cloudera is not something different with what we are telling, what Apache Hadoop does. Because Cloudera automatically uses the Apache Hadoop only. That's one and the same thing. Okay. As I said in the beginning itself, Hadoop has changed now. Okay. Cloudera, what it is doing, it is providing its own proprietary tools as well. Okay, like nav encrypt is there. How will you encrypt the data at rest? Okay, so that configuration is being provided by Cloudera. They have used their own tools, key trustee management server. Okay, how will you manage the entire cluster? How will you make the alertings enabled? Okay, alerting is basically enabled in the Cloudera manager itself. It's very easy. Okay, yes, so basic details, but I won't go into that detail in the classes for Cloudera. Yes, Kiran, Ravi, I mean, that is certainly a part here. Okay, so as a part of administration course, I explain everything about how to set up these VMs, how to create those these multiple virtual machines. I set up all these. I cover all this stuff in the class. Certainly, Natarajan, I think you will get a copy of this presentation soon after the class. Please stay tuned, and please do not forget, guys, to provide your feedback, be it a compliment, a suggestion, everything. Okay, please let us know. prerequisite of this course, Ravi, do reach out to this link and you will certainly be able to understand what are the prerequisites of this course. Okay, I would say a basic Linux administration is required. Yes, Vikas, but not in that detail. Okay, very basic one. Okay, so I think that's all, guys, from my side today. Thank you all for joining in. Uh, Please reach out to our support team to have if you have any queries. Okay, we'll certainly respond to all of those. Thank you so much. Have a very good day. Have a very good week ahead. Thank you. Cheers. Bye, guys.